right, say hi to DJ.
Hello class, welcome to the Palos Verdes Peninsula here in sunny Southern California. Today we're going to go on a little bit of a trip around the peninsula and talk about some of the geology and of course oceanography that we have here right off of our coast. So I hope you guys enjoy, and I will be answering some questions, and hopefully you'll learn something from this.
Nice.
All right, so here on the Palos Verdes Peninsula, we're home to the California borderland, which is being sheared by the San Andreas Fault, as many of you guys know from the movie, right? So it's not quite as dramatic from day to day as that movie might suggest, but the peninsula here is one of the examples of the interesting morphologies that occur, meaning the shapes that are made by this stress of these two plates rubbing against each other. And you can't really see Catalina Island, but it's out there, I guarantee you. And what these two plates rubbing against each other creates are these series of bathtubs all along the coast of California. And the Catalina Islands are actually, you could think of it as the other side of the bathtub from the Palos Verdes Peninsula. And this peninsula is made of a type of sediment called kaolinite, which is a clay that swells when water touches it. And so what happens when you develop that type of land that will swell when people start watering their gardens and build water tanks and everything, and those leak out into the peninsula, the ground swells and then you get landslides. And so we're going to actually drive over an active landslide. This whole peninsula is kind of sliding into the ocean, and most of the houses on this side of the peninsula have had to be removed because it's an active landslide. So if you ever get a chance to come out here, right now we're in Del Cerro Park at the top of the peninsula, and then we're going to drive down along the landslide, and we'll end up at the tide pools at White Point Beach. So I really hope you guys enjoy this journey we're about to take you on, and you guys are lucky EPSS 15 students, so I'm looking forward to it.
Yeah, this is also the first time we do this, right?
This is the first, not my first time, but this is the first time for this class that we're filming something. So
yeah.
So be patient with us. The California coast is being twisted and deformed by this plate sliding against it. So as that happens, you can kind of imagine the land is like kind of coming off in chunks and rotating around, and that process creates these like bathtubs all along the coast. So it's not, when you think of off of the coast of a continent, you think of a continental shelf and then the gradual slope, and then it kind of leads to an abyssal plain. But here, rather, we have a series of dips like this because of the tectonics of the area.
Yeah, that's cool.
Does the dip eventually go down to abyss?
Eventually it does end up at the abyssal plain, yes. But you have these series of, and that's why the kind of the ocean chemistry and ocean biology off the coast of California is pretty unique as well, because of this series of bathtubs that become anoxic, and you get, lots of different types of organisms and stuff. There's also, we're going to see some hot springs today with mats of sulfur bacteria that you can actually just see down at the tide pools, and there's also methane seeps and hydrothermal vents off of our coast. So
nice.
It's a very cool place. We're lucky to have it.
Yeah.
Does this structure allow more animals to live here, or?
Well, so the coast of California is called an upwelling zone. So that means that nutrient-rich water from the deep ocean gets pulled up into the surface, and that allows for things like our kelp forests, and it allows for a great amount of biodiversity in our oceans. So that's why the waters here are a little murkier. You don't get that crystal clear beach thing, but it's because there's so much life in our oceans.
Mm-hmm. Very nice. And the very unique, I guess, bathymetry stuff near this coast is due to the landslide.
Part of it is,
Part of it is due to
and
the landslide.
tectonic, and you get some of those like canyons and stuff because of that. Yeah. So if you guys remember the tectonic maps, or not tectonic, the bathymetric maps that we made you fill out, the ones for this area could be kind of interesting.
Yep. Right, remember there's one map that's actually showing somewhere over here.
Yeah, it was around here, down in actually Redondo, I think. Yeah, which is up the coast.
All right, okay.
Alrighty. before I get a parking ticket. All right, welcome again, EPSS 15 students. This is DJ and Yufan, and we are currently driving over an active landslide here on the Palos Verdes Peninsula. And as you can see, there are pipes above ground because the land is actively sliding. The road has to be constantly repaved, and that leads to this very almost roller coaster-like road that we're on right now, where there's lots of patches being worked on, and it's a pretty interesting place. And all of the houses that are to the left of us all have to be on rollers, actually. So the houses are actually have wheels on them because of the active landslide. And most of the houses in this area have been removed because of that reason.
Look at this pipe.
Because of, yeah, look at the pipes above ground. It's kind of interesting. So yeah, this is the active slide area. So if you're ever driving along the Palos Verdes Peninsula, you'll get to experience this wonderful, wacky road. So next stop will be White Point Beach, so we'll see you there.
Bye. Now we just arrived at the White Point Beach. So DJ, what's special about this place?
There's a lot of things special about this place. It's a great place to view the intertidal habitats of our ocean critter friends, and it's also a great place to see some of the geology of the area. So we're going to be taking a look at a little bit of both. It's also not such a fun place to park at, so
Apparently.
there's also sometimes, as you might have seen, classic car shows here with lots of lowriders and kind of old 1920s style cars. It's a really fun place, a lot of Southern California culture. There's always people out here barbecuing, having a great time, so it's a fun place to come. Surfers, of course, are always out here, and it's a very fun place to spend a weekend afternoon.
Look at this cliff.
Hello EPSS 15 students. I hope you enjoyed the drive down the peninsula. We are now here at White Point Beach. But before we get to the actual water and the tide pools, I wanted to point out to you this very interesting geological feature here. This is a perfect example of what's happening to our coastline because of the San Andreas Fault. Like I said before, it's spinning those bathtubs off of the mainland continent and contorting and twisting the land. And you can see here that this feature here is a great example of the rifting that's occurring. And so there's something called the law of original horizontality that means that all sediments are deposited in horizontal layers going down and down. But when tectonics comes into play, like our San Andreas Fault, things like this can happen where they twist and bend, and the layers are no longer in horizontal formation. So this layer behind me and most of the California coast down here in Southern California is made up of what's called the Monterey Shale. The Monterey Shale is a really important for rock formation, not just for California and not just for geologists, but for the development of the American economy, because the Monterey Shale, as you can see here, is full of oil. All of this is oil, and you can see the shale here has been deposited in its horizontal layers. This is all dead marine organisms, right? So it's like the siliceous oozes that we talked about has now become compacted into this shale. You can see the layers of, you can imagine the sediment going down and eventually forming these layers. And that black stuff in between is all of those dead marine organisms that have now become oil. And that's why the California coast has become such a hot spot for petroleum extraction. So It's all because of this, the monoracio, which we can see here, and we can see being deformed in the formation behind me. So next we're gonna check out some of the tide pools. So come along with me and we'll have a little bit of fun. All right, welcome students to the tide pools. Now the main event of our program today. So these tide pools behind me were made from, you've heard me talk a lot about the San Andreas Fault as a transform fault, right? But before those two plates were sliding against each other, they were subducting under each other. And if you remember what we talked about with subducting plates, what comes along with subducting plates? Volcanoes. So these tide pools are actually evidence of California's volcanic past. And they're primarily made of basalt flows that came out of the volcano millions and millions of years ago. However, one thing you'll notice is that some of this looks like man-made. It doesn't really look like it came from a volcano.
Yeah.
And that's because this was the site of a hotel and spa back in the 1920s or thereabouts. And it was all demolished, and this was all created into a public beach. So that's a bit of the history of this area, and now we're gonna get into the tide pools themselves.
Okay.
All right, so we're here at a very interesting area of the tide pools, and this is where you can actually see the sulfur bacteria, that white kind of film that covers the rocks. Those are deposits of sulfur that are created by the bacteria that are breathing that sulfur to do their metabolism. And if you were here right now, and if you ever come here, it smells like sulfur. You can really smell it in the air,
Like a spoiled egg.
like rotten eggs, exactly. So there will be a lot more of these all around the tide pools, but it's a very interesting, and this is why actually the hotel was originally here, was because the sulfur comes from a hot spring. So some of the water here is quite warm because of that.
Okay.
The water's really warm, not crazy warm, but some of
Yeah.
the tide pools get really warm.
So you can see mussels everywhere and shells.
All right, here what we see are these kind of veins going through the rock of this what looks like crystalline white material. And this is actually probably something like gypsum or calcite or aragonite. And what this is back from when it was basalt, when it was an active lava flow, there are geothermal fluids that kind of run through the cracks of the rock and deposit these bright white minerals in them. So that's what we're seeing here. All of this is the leftover of these geothermal fluids crystallizing out of the volcanic formation. So
Yeah.
really cool.
Yeah, you can also see it over here. Right, it's everywhere.
It's everywhere.
It is.
So this is a sea anemone, and fun little thing you can do is if you touch the middle of it, it will wrap its tentacles around you. And that's to catch prey.
This is pretty cool.
Okay, so Yufan, I'm gonna speak a little bit, and then you can film the tide pool.
Yep. Be careful. You guys can see the crab? Yeah, it's moving. There are also some of the shells, yeah, over there. There's another crab. It's a big one.
Look at the crab eating
Crabs.
fish.
Oh yeah, let's
The
get
crab
the
is
crab.
eating fish.
There's a crab eating the fish. Got fish.
Oh my god.
Okay, Yufan.
Yes. Back to you.
Hello, EPSS 15 students. Welcome again. We are here at a tide pool, and you can see there's that film of sulfur on the bottom, indicating that we're still near the hot springs. And if you look closely, you'll see some crabs eating at some of the dead fish and stuff down here. This is a great example of a subtidal pool, the rocks around it could be more of a middle tidal pool, and back there would be a super tidal or the spray zone. So we're going to see lots of different organisms in these pools. Hopefully, when we're shooting the pools themselves, you'll get to see some of them, and hopefully you can come out here and experience it for yourself and get some awesome wave photos. Because I have a few of them, and let me tell you, they're pretty epic to be standing up there with the waves behind you. So yeah, it's a lot of fun here. So one thing important to point out while we're here, and that's important for your lab, is the tides. So we are here today at the low tide, not the lowest low tide, but the second to lowest low tide here. The lowest tide was at 4 a.m. and as much as we love teaching you guys, we're not going to come out here at 4 a.m. But what's exposed right now would otherwise be underwater during a high tide. And so what you're seeing is some of the creatures that would be in the middle tidal or subtidal area. And a ball. You can see our little barnacle friends clinging to the wall, and some clams clinging to the wall. And as you go farther out into these into this formation here, you can see the rocks are studded with these creatures that are clinging on the side. So those are our barnacle and mussel friends. And you'll also see this area is littered with larger crabs. Now earlier we saw some hermit crabs, but if you're lucky, what you'll see are some larger crabs that are scuttling into their burrows as we walk along. So the tides are coming in, you can see the water's rushing in behind me. It's so much fun.
Yeah.
I hope you make it out here sometime.
Very photogenic place. Exactly.
Pool, we can see that we have a lot of these little hermit crabs. At first I thought they were snails, but when I picked one up, you can see one moving here now. It's actually a hermit crab, and these are all over this area here.
Can you pick one up?
Can I pick one up? Yes. So if we pick one up, so it's hiding in its little shell there, but it's in there. You can kind of see it's some of its body, but if I put it back down, it'll probably start scurrying away. Here we have a little crab, if you can see that.
Yep.
A little crab friend there, and another sea anemone. But the diversity in this particular pool is a little bit different than the other one. You can see it's a lot more hermit crab dominated, which leads us to believe that maybe the physical conditions of this pool are a little different. Maybe it's not submerged as often, or maybe it's submerged more. So those are the kind of subtle differences that you can look for when you come out here yourself.
Yep.
And here we have another little sea anemone. Boop.
And for sea anemone, they are carnivorous.
What?
They are carnivorous.
Yeah.
Yeah.
They're related to jellyfish, or not jellyfish, sea stars.
Sea stars.
Not like, they're like this thing. Right here, we have what we can see is, I believe, a sea urchin here in the water. And those are found in the subtidal zone, which is a good indication that this water right here stays fully submerged, regardless of what tide they're in. So this guy's just hanging out there.
You can see a hermit crab over there. Yeah.
Oh yeah, there's a little hermit crab right there.
The black shell.
Which are normally found in more subtidal zones. So you see kind of this mix of organisms. Things don't always come out as easily as the graphs that we present you in lab. Yeah. But this is a great little tide pool here with a little more diversity in it.
Yeah.
So.
And just show the basically how large they are, the scales. Maybe we can put your fingers over there.
Yeah, you can see that it's very small.
Very small.
Yeah, it's tiny.
Tiny little guys. So this tide pool here is a great example of what you've been seeing today, which is unfortunately that the biodiversity of these tide pools has taken a really big hit in the past year or so. And that is because of something called the sea star wasting disease. So it's a disease that affects starfish and sea stars that is still not well understood. But these tide pools used to be brimming with life from sea stars, sea slugs, sea cucumbers, a lot more crabs, a lot more fish. But over the past year or two, because of the sea star wasting disease that has killed all of the starfish and sea stars, the diversity of these tide pools and the amount of creatures in these tide pools has vastly decreased. There's a lot of research going on to find out what causes this wasting disease. It has had huge implications for our kelp forests as well, and for even the sea otter populations off of our coast. So it's definitely something. Sea stars and sea starfish are keystone species in our intertidal habitats, meaning that the loss of these organisms has devastated these tide pools. There's a lot of research going into what's causing it, and hopefully in the near future we're going to be able to reestablish our starfish off of our California coast and bring back that eco-diversity that we used to have. So I hope you guys have had a great time here at the tide pools, and I hope that you guys learn something and get a chance to come down here yourself. Thank you.
Yep.